Hi, how are you? In this video, I'm going to correct the word problem number 3 and the number 5 because the other exercises are related to percentages. So 3 and 5 are a little different. So let's start with the number 3. So read the word problem carefully. So to explain this exercise, I'm going to use a table like this one, and this is the typical table that we use for functions. So we have the time and the number of cells. Okay, as there are 5 cells at the beginning. Okay, there are 5 cells at the beginning. So in the time, we write the minute number 0. Okay, the number 0 is the beginning. So this is the beginning. So at the beginning, there are 5 cells. After 1 minute, and here after 1 minute, there are 10 cells because the cells double. Double means we have to multiply by 2 the number of cells. After 2 minutes, there are 20 cells because there were 10 cells, but they doubled. So there are now 20 cells. And so on. Okay, we have to multiply by 2 all the time. Okay, so the formula that we are going to use is slightly different from the other problems related to percentages. So the cells, or the number of cells, is equal to the cells at the beginning, so 5 cells at the beginning, multiply as they multiply by 2. Okay, they multiply by 2 all the time. We have to multiply by 2. And this is a power that depends on the time. So to the power of t. So to answer the first question, determine the number of cells after 40 minutes, we have to substitute the t for the number 40. So the cells will be equal to 5 times 2 to the power of 40. So this is a big number of cells because we get, let me see, we get 5.498 times 10 to the power of 12 cells. To answer the question B, determine how long it would take the population of cells to reach 100,000 cells. We have to substitute in the cells for 100,000 equals 5 times 2 to the power of 40. Sorry, 2 to the power of the time, because we have to find the time to get 100,000 cells. Let me clear this. So to solve this equation, I have to use the logarithms. So I'm going to write logarithms in both sides of the equation. All right. So the log of this number, as this is the base 10, has an exact solution. It's an integer. This logarithm is equal to the number of zeros. So this is equal to 5. It's not necessary to write the solution of that logarithm, but it's going to be shorter to write. For these numbers, we don't have an exact logarithm. So I'm not going to calculate the solution because it's going to be a decimal number. So according to the properties of logarithms, I can write the log of 5 plus, I bring down the exponent t times the log of the number 2. So I'm going to move the log of 5 is adding, so I'm going to move to the right to the left side subtracting. So I get 5 minus the log of 5 equals to t times the log of 2. And finally, I'm going to solve for the t. The t is going to be 5 minus the log of 5. You cannot do any type of simplification here, okay? You have the 5 here, the log of 5, but they are completely different numbers, okay? So don't simplify anything here. So over, as the log of 2 is multiplying, so we isolate the t by dividing by log of 2. So I write by divided by log of 2. So I calculate this, and we have the time is 14.3 minutes. So this is the answer to question B. For the last question represent the formula on a coordinate axis for the first 5 minutes. Well, I'm not going to do it in detail. Let me make a graph. Okay. So I'm going to write on the x-axis the time. This is going to be the time. On the y-axis is going to represent the cells. So I have this is the 0. Okay, let me 1, 2, 4, 5 up to 5 minutes. And this is going to be from 10 to 10. Okay, I'm going to represent only the first minutes. For the at the beginning, at the minute number 0, there were 5 cells. So 5 cells. I make a point here. After 1 minute, there were 10 cells. After 2 minutes, there were 20, then 40, because we double all the time. And then 80 is going to be 67. Okay, so as you see, the graph is going up very, very fast. So we call this exponential growth because the growth is very, very fast. Okay, this is typical of bacteria and viruses. Okay, the growth is very fast. Well, let's see the word problem number 5. We have this formula, and we have to solve how many bacteria will be after 25 minutes. So I only have to substitute in the t the number 25. Okay, there is a mistake here because the p is for population and x is not x, it's t, because the variable that is on the formula is t. Okay, so here is t, the time. So after 25 minutes, so we'll have, okay, this is, sorry, it was a t, 50,000 multiplied by the number e, okay, the exponential number, to the power of minus 0.6 times 25. The result is approximately 0, okay, 0 bacteria. The second question is about the time again. So how long will it take the number of bacteria to reach 1,000? So I have here 1,000 equals 50,000 multiply. Okay, I'm going to write all the formula again. Here the variable t, the time, so I have to solve for the t. Well, so to solve this type of equations, I need to use the logarithms, as I said in class. So write the logarithms in both sides of the equations, sorry. So I use the properties of logarithms to separate this multiplication into an addition of two logarithms. And then I'm going to bring the exponent down as a factor, okay, multiplying. The log of 1000, this logarithm is base 10, so you can write the solution because it's going to be exact, the number. It's a whole number, okay, 3. It's not decimal, so equals the log of 50,000 plus, okay, I put the exponent as a factor, and then the log of e. All right, so I have to solve for the t. I have to isolate the t. So I'm going to move this number to the left, subtracting. And on the right side of the equation, I have minus 0.6 t multiplied by the log of e. So I finally, to find the t, I'm going to write the t on the left side. I have 3 minus the log of 50,000 over minus 0.6. Okay, this number is multiplying, so to okay, to make it disappear, I have to, or simplify this, I have to move this number, I have to divide by 0 minus 0.6, okay, the other side of the equation. And to eliminate this, the log of e, I have to divide again. It's multiplying, so I'm going to divide all the equation by the log of e as well. So I solve this operation and I get 6.52 minutes. So this is the solution. So that's everything. Thank you and bye. See you.